The last example of the pitfalls of AI thinking, it could be summarized as saying that if you have a bunch of solutions to a problem, then averaging them together doesn't always give you a solution to the problem. And which just reminded me of something else that's not right about training data, so having to do with dimensionality. Maybe I can get back to that. You're right, soft spine. So the average solution is not a solution. And the illustration of this is as follows. I worked at a dental part manufacturing company, and the input to the system would consist of a three-dimensional model of a place on a real person's mouth where there was a missing tooth. It could be much more complicated than that, but the basic idea was you've got a model of the tooth in front and model in front and a model of the tooth in back, and you've got knowledge about where someone's already put an implant. Okay, now you're trying to design the abutment that's going to go into the implant. So you have people sitting there adjusting the angles of the screw and or taper and the shape of the thing, and they arrive at a viable answer that gets shipped to a dentist who goes, yeah, thanks, great, it's a beautiful abutment that you've made for me. And you can take three different designers' results from that same input, and they might come up with different answers. And this is a matter of fact that you average together those answers and you get an abutment that's kind of a mush. It's not right. And that somehow, and this is the phrase, that the design needs to have its own spine and can't be derived from averaging other design spine. Now, that's going to have to be a basic principle throughout the relationship between an organism and the world around it, which is the extent to which the designs whereby an organism fills a niche are predetermined by the shape of the niche or predetermined by the capabilities of the organism. Never going to be able to resolve that completely, because that's one of those fun things that sits there as generating discussion without getting resolved. And the same is going to be true here, although I forget what this analogy was about. But I was telling you about the pitfalls of AI and how, you don't know whether this design that you're trying to find, the machine is going to discover the design. You don't know whether that's going to be possible. The major advances in how neural networks worked came about by building some design things into the neural network, sort of some really good things like linearity. I can't remember the name of the neural network that accomplished shape invariance of shape when you move it in a scene. I mean, you want your neural network to come up with the same answer when you move things around. They had to build a special kind of neural network in order for that to work. And I heard that somebody finally explained to me that the Google transformer architecture for neural nets is the ability to detect sequences and measure sequences. And that sounds really cool. I'd love to know some things about how it works. Apparently, that was essential to mapping pairs of input and output of parts of speech that they do and use for ChatGPT. So the pitfalls of AI are that you're asking the machine to discover designs. You may not be asking the machine to discover it. You may be asking it to do something pretty routine, and then it'll work just fine. And you could say that a machine understands what you're saying when it gets you a Coke if you ask for one, orders you a pizza if you ask for one, plans you a trip if you ask for one, is your best friend if you ask for one. But I do want to say something to the developers of AI for a second here. When you're doing what they call supervised training, where you go, no, that's not an example of this, it's an example of that. is that when you've got a neural network that you're training and it's come along pretty far and you've added a few more data samples and suddenly it starts giving you answers that are not quite the ones that you want, you have a tendency to sort of say, no, no, that example should go over there. And what that ends up doing with supervision is oversampling right along the boundary between the two categories that you're trying to classify. So that's a threat to the system because it creates a definition of the average that's biased towards the midpoint between two very distinct things. And it's sort of like you're building up ambiguity as you try to solve the problem by further sampling right between the two things. It's like, is that a bicycle? Is it not a bicycle? You keep putting the samples in there. It's not a good idea. And I think it's inevitable. One of the things that's happening with ChatGPT, it may have gotten overtrained by now. And you've got categories intermixed with categories that are, if you could see the geometry of it, like the guy said in the movie, you never stop vomiting. So anyway, yeah. And then there's another pitfall for you developers, which is that supposing you're designing an algorithm that's going to recognize this in the input, recognize a pizza statement, an ordering statement from other types of statement, or um, you try to design it to recognize something in particular. Okay. In my case, I was trying to do that with ring-shaped patterns of defects on a semiconductor wafer. Not exactly a pizza, but a sort of similar visualization. And what happens is that it works fine, and then you give it an example that it gets the wrong answer for, leading you to want to oversample these boundary cases. But there's something else that happens when you have an example. It's not quite the one that you thought of when you were designing or training the system. Is that you go, oh yeah, that's one too. So you put it into the category of the things that you want. You just broaden the category a little bit, and that should be fine. And you have some more examples, and pretty soon you see something that's you wouldn't have called that a ring. You wouldn't have called that a ring of defects. Did I just? Yeah, you wouldn't have called that a ring of defects. You would have called that a crescent of defects. But it's ring-like enough that you're gonna train the system to include that in the ring. And what happens is that rather than training the system to classify the way you classify, you begin shifting your own thinking about what the classification is, so that you are more in agreement with your algorithm. And I call that pattern recognition algorithm developers hypnosis syndrome, which is acronym PRADHS, Pradis. And it can happen. Uh, so I was going to say maybe that's if you don't have a spine. Uh, so there's some real threats with oversampling ambiguous cases. And what I started to say earlier is that um, the ambiguous cases may in fact indicate a dimension that you're not paying attention to. And what you end up doing is projecting classified sets onto each other in a lower dimension. Just because you're using a billion parameters doesn't mean you've got the dimensionality figured out. Projecting it to a lower dimension and the data sets become a mess. Not that I would know. I don't have the ability to visualize anything anymore. So something about self-driving cars. I might as well also say something about general AI because Elon Musk comes to mind. And some of the things he says are, he's a person who's in the world of marketing and sales, and they know things that I don't know. So I do, if I tried to say things about what they say, I'd be not knowing what I was talking about. So why don't I just go ahead and do that too? Um, Musk thinks that there's going to be a super intelligence coming along, around the corner that's going to just be much smarter than us, I guess. And I ask, how would you ever know that it was smarter than you? Because I see some people who are faster than me at certain types of problems, and I accept that there are much smarter people than me. And I also see people who can remember more than me, and I can certainly imagine a computer that just remembers everything, if as if both what was said one way and what was said the other way. It doesn't have necessarily. Anyway, I can imagine that. But I think pretty much it would just come across as some sort of piece of material that had these weird filtering properties rather than as an intelligence. I don't know. I question whether much more than what humans can understand could be conceived of. It's not just like if the tree fell in the forest, would anyone hear it? It's if a thought was in the mind of God, would everyone be able to understand it? Which I think the question answers itself. So that's probably just about my entire rant about AI, fear of robotics, um, measurement and detection, feedback loops, the effect of um, brain modeling on electronic device manufacturing and device design. So it's all a lot of fun. Good luck to you.